Consider a vector A making an angle theta with the x-axis. Suppose this is our x-axis and this one is the y-axis. This is the vector A. And the angle this vector make with the x-axis, let the angle this vector make with the x-axis be theta. Then this vector A can be resolved into two components, that is one along the x-axis and one along the y-axis. That process is called the resolution of the vector. So how will you do that? For that, let's name the endpoints of the vector as O and P. Drop a perpendicular from the point P to the x-axis like this, and let's call that point as M, and drop another perpendicular to the y-axis and let's call that point as M. Then let's take this OM, length of OM be x, AX, and the length of AN be AY. So you have a right triangle here, OMP, and taking the cos value before that, you just write consider triangle OMP. We have, since OMP is a right triangle, you can take the cos, sine and tan. So cos theta is equal to what will be cos theta? The adjacent side by hypotenuse, that is OM divided by OP. Let's assume that this length OP be the magnitude of, it's actually the magnitude of the vector, and let's represent that length as A. We have OM is equal to AX divided by A. Therefore, if you take this A to the left, you get A cos theta is equal to AX. That is AX equal to A cos theta. AX equal to A cos theta. And this one is called the x component or horizontal component of the vector. AX. That is A cos theta is the horizontal component of the vector. Similarly, if you take this value of, or if you take sine theta, you will get sine theta will be PM divided by OP. And PM will be, if this is AY, ON is equal to AY, then PM will definitely be AY. AY divided by A. Therefore, AY is equal to, taking this A to the left, you get AY is equal to A sin theta. And this is the Y component. So this is the X component, and this one is the Y component. X component and Y component. Also, if you take this triangle in the vector form, that is, if I take the direction of OM also, that is in this direction OM, and MP in this direction, and if you use the triangle law of vector addition, then you get OM plus the vector OM plus MP. The closing side should be, or the third side should be in the reverse order, that is OP. This is actually the triangle law of vector addition, that is OM plus MP is equal to OP. Then we have the vector OM is equal to, the magnitude of this vector is AX, and it is along the x-axis, and the unit vector pointing the x direction is I cap, so it is AX I cap. Similarly, MP is equal to AY, the length of MP is AY, and it is pointing in the positive y direction, so you can assign the j cap, unit vector. Therefore, OM is equal to AXI plus AYJ is equal to A. Therefore, A is equal to vector A is equal to, you can write this vector A as AXI plus AYJ. Clear? Also, you can write, instead of AX, you can write A cos theta. So this will be this is equal to vector A is equal to AX will be A cos theta I plus A sin theta j. AY is A sin theta. Clear? So this vector can be represented using the horizontal and vertical components. Then you should note certain points in here. Like, if what you get if you square and add the components, that is, note what is the value of AX square plus AY square. This is equal to, instead of AX, you can write A cos theta whole square plus AY equal to A sin theta whole square. This will give you A square cos square theta plus A square sin square theta. You can take this A square out, A square into cos square theta plus sin square theta. So this will be 1. A square into 1. You know the identity. Sin square theta plus cos square theta is always 1. That is, AX square plus AY square is equal to A square, or A is equal to root of AX square plus AY square. Clear? So if you add the components, if you add the squares of the components and then take the root, you will get the magnitude of the vector. Sometimes this A is called the parent vector. So you will get the magnitude of the parent vector. Also, if you take the tangent, that is tan theta. Now, if I take AY and then divide it with AX, what you get? AY is A sin theta and AX is A cos theta. Cancel this A and A. What is sin theta by cos theta? Tan theta. So AY by AX is equal to tan theta. Clear? So as for the summary, any vector A can be resolved into horizontal and vertical component, that is AXI plus AYJ. Point number 1. And the value of AX will be A cos theta and value of AY will be A sin theta, where A is the magnitude of the vector and theta the angle made by the vector with the x-axis. Then AX square plus AY square, that is sum of the, this is the second point, this one is the third point. That is, sum of the squares of the components will be the square of the magnitude of the vector. Also, the tangent, that is the tangent of the angle the vector make with the x-axis, will always be the ratio of AY to AX. The ratio of vertical component to the horizontal component.